In this video, we'll continue estimating the area under a curve, but now we're given tables of points. So let's try this problem. Use the table below to find the lower estimate for the area below the graph of f of x. So we're not given an actual formula, we're just given a table of points. So it's hard to tell what the lower estimate is or the upper estimate based on just the table. So let's plot these points and then connect them is kind of nice to see too. But then what's really helpful is to draw vertical lines down to the x-axis. So now at this point, we can start to visualize some rectangles, and the lower estimate will be the area that's less than the actual area. So let's just focus on this point right here. If we drew a right rectangle, meaning that this is the right side of a rectangle, this area is bigger. This will be the upper estimate. And notice that happens here too. If the area is above the graph, or if the rectangle shows above the graph, then this will be the upper estimate. So instead, we need the left rectangles because these were the right sides. We need to do the left rectangles to get the lower estimate. So we're going this way. So you take your pencil and you make this the left side of a rectangle and then just go this direction. So now we have 5 rectangles. They're all on the left. This one's technically a rectangle itself, like it's a horizontal line there, but that's okay. Okay, so now what you could do is just find the area of each one of these separately, which is totally fine. But I want to go back to my insider info of the left rectangle uses the A, not the B, and the right rectangle uses B, not A. Just so you can see that in table form, these are the y coordinates here. These are the heights. The height of each rectangle is in this bottom row right here. So what we need to do is remember that the left rectangle uses A and not B. Notice that we're going to be, for this first rectangle, we're going to be using f of 0, which is 2. And the next one is f of 3, f of 6, 9, 12. We will not be using 15. These are all the heights of our rectangles. So we're going to be starting with this one. We're going to use all of these, but we will not be using this one. So that's when I say that the left rectangle uses the A value, but it doesn't use the B. So our function, we're going to be using f of 0 to get the height, f of 3, f of 6, f of 9, f of 12. And we're going to be using all of these values for the height. So when we add our area, like we're going to find the area of each one, the area of this will be, in this case, delta x is 3. So it'll be 3 times f of 2, 3 times f of 3, 3 times f of 6, 3 times f of 9, 3 times f of 12. We will not be doing 3 times f of 15 because that'll take us this far and we don't need to go that far. So each one of these represents the height, and delta x in this case is 3. So when you add all these up, times it by the delta x, total area is 84. So that was kind of long-winded. I'm going to do this again. We're going to do the upper estimate this time. But I'm not going to go through it like crazy, like I just did, because now I want you to see that the upper estimate, we did this already, is going to be the right rectangles. It's the one that's larger than the actual estimate, or the actual area. And notice that because we're doing the right rectangles, so in this case we're using right rectangles, we're going to be using B and not A. So when we want to find the height, we're going to start with 15 and work backwards. And we will not be using this one. So you can look at the table and know that you're going to be adding up all of these heights right here and then multiplying it by delta x again. This is the height times the width. And in this case, the width was 3 again. So that's the upper estimate. Again, if you don't quite get the table thing that I'm doing right now, then just find the area of each one separately. It's all good. Everyone's visual. I'm very visual. It took me a long time to see this on the table. I like to draw it out myself personally. Okay, let's do a piecewise function. So evaluate the integral from 0 to 9 of f of x using geometric formulas where f of x is this crazy piecewise. So we haven't learned integration formula stuff yet. So everything we're doing is just area under curves. And all we know right now are geometry formulas to find the area. And that's what's so awesome about calculus is you'll be able to find the area of like curvy things and irregular shapes. But for now, let's stick with geometry. So let's draw this picture. This is y equals x from 0 to 2. Y equals x just looks like this. Slope of 1 goes to the origin. Y equals the absolute value of x minus 4. Absolute value is a v, and the minus 4 on the inside means that it's been moved to the right by 4 spaces. That's a translation. And then this is y equals 3. Well, that's just a horizontal line through 3. But we only see things from like the y equals x. We only see it from 0 to 2. So we're only going to see like this much of it. The absolute value form or function, we only see it from 2 to 7. So we probably just see like this much of it. And then 3, y equals 3, probably only see this much of it. So like put those pieces together. It's kind of out of order here. This one's going to come first, this one next, this one next. And you can always see if they connect by plugging points in. So when x equals 2, that's when this one stops. So when x equals 2, y equals 2, there's a point at 2, 2, and that happens right here. And then when this one starts, when x equals 2, y also equals 2. So this is going to look like this, and then it's going to look like this. And now at the point 7, when x is 7, this one stops. And it stops when y equals 3. And notice that this is where y equals 3. Okay, so that's just a quick recap of Piecewise. Hopefully you're good at this by now. Here's a picture of this graph. And evaluating the integral is finding the area underneath of this. So here's our y equals x from 0 to 2. Here's our y equals absolute value of x minus 4 from 2 all the way to 7. And then here's y equals 3 right here from 7 to 9. Okay, so let's just find the area. Notice that it makes a triangle and a trapezoid. Or if you want to, you can break it up into 2 triangles here and do 2 separate ones and double it, or I don't know, I wouldn't do that. Or if you don't remember the trapezoid formula, then make this a triangle and a rectangle if you want. Totally up to you. I did a triangle and a trapezoid. So triangle is 1/2 base times height. Base is 4, height is 2. Trapezoid is 1/2 times the height, which is in this case 3. And the bases are from 4 to 9, that's 5. And from 7 to 9, that's 2. Add those up. This part is the 2. I'm sorry, this part is the 4. 1/2 times 8 is 4. And then this is 3/2 times 7. And this was 8 over 2. You had to get a common denominator, and that's where the 29 halves comes from. And that's it.